In last week's video, we went over the different types of mass timber framing methods, highlighting the load-bearing walls, post and beam, and post and plate methods. In this week's video and the coming 2 weeks, we will explore each of these methods in more detail, starting off with the load-bearing walls method. Load-bearing walls are a fundamental mass timber framing method used in construction. Unlike other framing methods that rely on columns and beams, this system uses structural walls to support both vertical and lateral loads. The walls, often made of engineered timber like cross-laminated timber, serve as the primary structural elements, distributing forces efficiently across the building. The result is a stable, durable, and even well-insulated framework. This method can be used independently or in combination with columns for additional support. Load-bearing walls require a high volume of material compared to other methods. This results in heavier structures that may necessitate stronger foundations compared to other framing methods. One of the advantages of this method is the relatively low labor skill requirement. Since load-bearing walls involve straightforward panel assembly rather than intricate joinery, workers can construct these buildings with minimal specialized training. Because load-bearing walls are typically prefabricated off-site and then assembled on-site, construction is very fast. Compared to the post and beam method, which requires additional time for beam placement and bracing, load-bearing walls allow for faster overall build times, second only to the post and plate method. Load-bearing walls offer superior load distribution by distributing forces evenly across the entire wall surface, eliminating concentrated point loads. Unlike column-based methods, where loads are transferred through specific points, load-bearing walls provide a more uniform and stable distribution. One of the strengths of load-bearing walls is their excellent shear resistance. Since the walls act as rigid panels, they inherently resist lateral forces like wind and seismic activity without the need for additional bracing. Despite relying on walls for support, load-bearing wall systems can achieve relatively long spans. Depending on material strength and design considerations such as the thickness of the floors and roof. While not as extensive as post and beam spans, they still provide more than enough design flexibility. Unlike post and beam systems, which may result in varying ceiling heights due to exposed beams, load-bearing walls ensure a consistent ceiling height throughout the structure. This contributes to a clean, modern aesthetic, enables more efficient floor-to-floor design, and simplifies suspended ceiling installation. Since load-bearing walls provide smooth, uninterrupted surfaces, interior finishing is very easy. Drywall, paneling, or other finishes can be applied without complications introduced by exposed beams or columns. A key trade-off with this method is the floor area occupied by thick structural walls, compared to column-based systems which maximize open floor areas. Load-bearing walls reduce usable floor area to some extent. One of the main drawbacks of load-bearing walls is their limited adaptability. Since the walls are integral to the building structure, they cannot be easily moved or altered, making future modifications challenging and limiting flexibility in the building's layout. Variants in load-bearing wall systems can include designs with or without columns. In systems with columns, load-bearing walls are combined with additional structural columns to provide extra support. This hybrid approach can also allow for greater spans when adding beams. while retaining the advantages of wall-based load distribution. In systems without columns, there are two main approaches. The normal approach relies solely on walls for structural support, offering simplicity and efficiency in construction. Alternatively, the notched variant involves the edges of the walls being notched to interlock with perpendicular walls or structural elements. This technique can enhance the connections and increase overall structural integrity. Load-bearing wall framing in mass timber construction offers a robust, efficient structural system with advantages in load distribution, shear resistance, and interior finishing ease. However, it does require careful consideration of material usage, floor plan flexibility, and space efficiency. In next week's video, we will explore the post and beam mass timber framing method. Stay tuned as we continue to analyze how different framing methods impact design, efficiency, and sustainability in modern construction.
Stay informed, stay inspired. TimberTalk.